Okay, let's recap what we have done. So basically this is our circuit diagram, a 5 volts power source, R1, R2 in parallel with R3, and we wanted to measure the voltage drop across R1. So then I need to put my multimeter in the voltmeter mode across R1, and I need to do in parallel. And here is my multimeter. As you can see, there are different functionality. So basically to measure, for instance, AC voltage, DC voltage, DC current, resistances, etc., and like diode and connection, and then the transistor parameters. In that case, basically, I have chosen the voltage, DC voltage part. And basically, you can also set the range. So, for instance, upper limit. So this goes all the way to 2000 millivolts or 2 volts. So if I had chosen this, for instance, you see it shows 1. So it basically tells you it's overloading. So it's like the voltage is larger than 2 volts. So that's why basically I need to choose the next range. But if I had, for instance, like chosen 200, it will still show, but with less resolution. Okay. So whenever you have an instrument, always choose the range that can accommodate the voltages and signals without overloading the instrument. Okay, but in this case, remember, the multimeter, voltmeter needs to be connected in parallel with the component R1 that you want to measure. The voltmeter basically has an theoretically infinite internal resistance. So the parallel combination of R1 with the internal resistance of this voltmeter is still R1. Therefore, this voltmeter does not interfere with your measurements. It wouldn't ruin the voltage, or it wouldn't change the voltage across R1. Okay, but of course, in reality, the multimeters, they don't have infinite internal resistances. You can find out their resistances by looking up their instruction manuals online or through the instruction manuals in the lab. Usually you see like on the order of 10 mega ohms or so. So it means one thing. So if you are measuring large resistances, then you need to be careful about the internal resistance of the multimeter. Actually, you can try, for instance, doing a similar experiment that we do here by using 1 mega ohm resistance and see if there is anything different. Okay, that's an interesting experiment. And let's look at how we connected the voltmeter in parallel one more time. So I'll go back to my circuit here. Sorry. And here you can see basically I've got the 3 resistors. So this was positive 5 volts, 0 volt return, and the red probe and the black probe for the multimeters. And this is R1. As you can see, the top LED of the R1 is on the same row with the red probe, and the bottom LED of the R1 is on the same row with the black probe. So this is basically how we do the parallel connection. But now basically the next thing that we will measure is the current through R3. So basically in this case, I'm not going to use multimeter in the voltmeter mode, but in the amperemeter mode. But don't do this at the moment. If I change to the amperemeter at this point, the fuse inside the multimeter will get burned. Okay, so be careful whenever you are making transition, and you'll see the reason why. So first of all, what I will do is I'm going to just turn off the voltage. I'm just going to turn off the power supply first, and to do this I always go to 0 volts first and then turn this off, because so that any transient when you switch off the instrument does not damage the circuit components on your breadboard. Okay, so basically, okay, so for the current measurement we need to think a little bit. So as you remember, current is not an across variable, it's a through variable. So basically, if I want to measure the current through R3, then my measuring instrument should be in series with R3, with the component, so that the incoming current I3 passes through the ampere meter, gets measured, and then the same current passes through the R3, okay? And in order not to affect, not to change I3, the ampere meter should have theoretically zero internal resistance, okay? So that basically the resistance on this branch is still approximately R3. Okay, so this is the next measurement. So I'll show you how to do the series connection. But just one caveat, okay, so like never connect an ampere meter in parallel with a component. Why? Because as I said, the internal resistance of the ampere meter is about zero, so that it does not basically ruin the measurement. But if you connect an ampere meter in parallel with a component, so let's say I put this in parallel with R3 by mistake, then you are short-circuiting the component. So R3 in parallel with 0 is 0. So the entire current will pass through the ampere meter, and it's usually a large enough current to get the fuse inside the ampere meter to get burned. So you can replace the fuse, but I mean, let's just use the instruments properly, and let's not do any damage to the components. Okay, so I'll change the breadboard to be able to measure the current passing through the breadboard. So first of all, I will disconnect my probes so that they don't get damaged by mistake. And one thing I'll do, so basically I have been using this plus, supplying this plus and minus through the directly on the probes, but now basically I want to do things more systematically. So I will first of all put the plus 5 volts on the red line, red vertical line, plus line, and then I have a jumper from the yellow jumper to power up the top part of the circuit. So this is like a more systematic way. And similarly, I will put this to the blue line, the ground part of the multimeter, to the ground line. And then I'll have, for instance, I'll then just put a jumper to the bottom part of the circuit, okay? So basically my multimeter, my power source is off at the moment, so I can basically do these modifications without any problems, okay? So this is basically still the same circuit yet. Now I'd like to basically take out R3 for the following reason. Remember, basically I'll need to disconnect the path to the R3 so that I can put my ampere meter. By the way, so it's written voltmeter. Yes, so voltmeter now will become ampere meter. Okay. So basically I will take out R3. Okay. And instead of R3's incoming path, I can first put the red part of my probe like this. Okay. So it will go to multimeter first, and whatever gets back from the multimeter, so it will get measured by the ampere meter thing. So I need to supply back to the circuit, but I'll basically supply this. So basically I'll do it in a radical way. So basically the red point, so basically the current will come through R1 and will get split to R2, and one part will go to the multimeter through this red part, through this red cable. It will go, it gets measured, and it will return back to the circuit with this black line. So now what I need to do is I need to connect this part back to the back to the bottom of the R2 using R3. Okay, so let me see if I can do it with a, well, easier way is like this. Okay, so let me do it in an easier way. Okay. So now R3 is actually placed upside down, kind of. Okay, so basically, look, so the current comes into two, R2, passes through R2 and goes to the ground. And the other current comes after R1, goes to multimeter through this red, gets measured, returns back through this black, and then R3, and then R3's top lead is now connected to the R2's bottom lead, but it doesn't matter, they will just go to 0. By the way, there is there's a very slight mistake, so you should be careful with connecting the resistors on the correct row. So let me do it. Okay, yes. Again, the top of R3 and the bottom of R2 are now connected to each other. So I'll put this again. Okay, so now let's measure the, so let me open up the current measurements. So okay, what do we expect? So 5 volts over, so let's do the math quickly. So 1.5, actually let's do it together. So we got, so the I total is, or through I1 is 5 volts over 1 plus 5k. So this is basically 3.3 milliamps, and through I3 should be half of it. Through 1.6 milliamps. So it's a small amount. I will put this. Okay, so I think our multimeter is not very well. So you can change the 1 kilo ohms with a different value, but for now let's see how it will measure. So I'll do. Okay, so this is like 200 milliamps maximum at the moment. Okay, but it should still be okay because I can measure up to the like 1 digit, so it can give me 1.6 milliamps. So let me turn off my thingy. So we are ready to give voltage to the circuit. Power up the circuit by 5 volts. And you can then see that the multimeter in the ampere meter mode gives us 1.5 milliamps, even 1.6 milliamps, which is what we expect for the current through the R1. Of course, you can increase the resolution, for instance, by doing this circuit with smaller resistance values, such as 330 ohms. Or another thing that you can do is just increase the voltage to 10 volts. You can select 3.1 volts, etc. By the way, maybe you might have heard the sound. Do you hear the sound? Sometimes when you increase the voltage beyond a certain voltage, certain value, then the internal relays inside these machines, they basically switch from one mode to another mode. That's why, so don't worry about that, okay?